Hello and welcome to this part where we will study pass by value in functions. First of all, we should learn how to declare prototypes and functions and what are actual arguments or formal parameters. Yes, arguments, formal arguments or actual parameters. So this is a simple program where I have three functions: f, sum, product. Here I have written product, here f and sum. So let's look at them one by one. This is a void type. So this function need not return anything. It does not take any argument. Same is the case with sum. However, product takes two arguments, two integers, and therefore product should return an integer. This is the body of function f. Every function's body is enclosed between two braces, and here we have sum. Note that when you declare a prototype, it must end with semicolon, all three places. But when you write a function, this does not have semicolon. This is called function signature, and this is called function prototype. Okay. Since I have declared product before main, this is not mandatory. However, you should. So I'll leave it. But since f and sum have been written after main, these are mandatory. If you try to comment them and build them, you have got issues. See, it says implicit declaration of function f, and it says conflicting type of sum, conflicting type of f for f. So it takes this name to be conflicting with this name because this is an implicit declaration. We must have the prototype. The rest are gone. Now, when you pass or when you call a function, this is the way you call. You write the name of the functions and the name of the arguments. The type is not needed here. So sum I comma j, product I comma j. Product returns an integer, so I can store that value into an integer. I can choose not to store this. I can delete this. But since I am printing p here, I should, right? This is where we have return statement. When a function instructions encounter a return statement, they return with the value. That is, if I write something here, say printf, and I try to print something, it will never print that because at this point it will return from this function. Okay. Now let us dissect it one by one. In main, I have declared two variables, two integers for simplicity. I having a value 5 and j having a value 7. Then I call f, which says welcome to function f. It will print that. Then I have sum. So I say sum is percentage d and I print I plus j. Note that I have said I is equal to 9. So I should become 9, right? Then I say P is equal to product ij, which multiplies I and j. So how much should be the value of P? 9 into 7 is 63 and 5 into 7 is 35. Since g in function sum, I have said I is equal to 9. So it should be 63 if this value is changed. But no, it will not be, because I have passed by value. When you pass by value, a copy of this variable is made. The actual I memory location is not used here. The value is used, but not the same memory location. This I's memory location is different than this I's memory location. So when you are making this change, then you are making the change at a different memory location. Therefore, this will not reflect here and will print 35. There is something called actual arguments or formal parameter. The name actual arguments is deprecated. This is where I and j are known as formal parameters. And this is where they are known as actual parameter or formal arguments, the alternate names. You can refer to specification about this information that they are deprecated. In future, they will not be used. So we are ready for a run, and let's run this. But before running, let's see some points. Okay. So comment them out. Say run. Okay. So it finds still function f. That is weird. Okay. Anyway, it should not find function f and sum. I'll say build it. Function f and sum are below this. It should. I have not made any change, so it may not be actually building it. Okay, here. So still it is able to find that. Okay, so that may be possibly by ID or by other mechanism, but you will certainly get warnings. Let's see this in Cvideo terminal. So we go to Cvideo drive, C, user, save, workspace, pass by value to the src. So I say gcc pass by value. So I got a warning. Note that it's a warning, not an error. So it will pass this and it will build the exe. If it would have been error, then it will not pass. So what I do is I delete this. Okay. Then I'll say gcc minus wall, which will enable all the warnings, and then say gcc minus w error, which will treat warnings as errors. Now it will not build that a.exe. See, those same things are treated as errors, and note that we have got more warnings. See, no a.exe. Therefore, there are few flags of GCC which I would like to point out at this time, which you should enable in your code. You will see this in Eclipse. So we go to this and we go to properties, go to C++, build variables, environment, settings. Okay. So we go to sequency compiler. You see -wall is there, but W error is not there. So what I will do is I'll put environment variable, where is flags, build variables. Okay. So should have it here. Okay. For now, what I will do is I'll put here by force W error, and I'll put two more flags, pedantic and MC. Okay. Now I try to build this. So it says errors. See. Okay. P undeclared. Since I have said MC, it will not allow me local declaration. Okay. What pedantic and MC allows you is when you say MC flag, that takes the MCC specification. It does not follow C99 specification anymore. So this declaration is no longer allowed. And since we have said W error, this is gone. So let's remove the MC flag. We don't want to do MC programming anymore. With C99, we want to do C99 part. Okay. ISO 90 forbids mixed declaration in code. So we need to give it ISO C99 flag. -std is equal to C99. Pedantic ensures that your code is of portable type, but still we have got errors. So to resolve these errors, I'll enable this name, right? So for F and sum, we have got errors. What if I disable this? Then do we have error? I'll build this. No, we don't have error. Why? Because when this name product is used, product has already been encountered by the compiler over here. But since it is our best practice, we will enable this. I'll enable this. Note that the name I and J are optional here. You need not write the names. But anyway, let's write the name. Now let's run the program for what we have discussed till now. So you see, first F was called, and then sum was called. So sum prints 12 and product is 12. See. So this is what we have discussed in this pass by value. The crux of this section is this line. This is very important. This change is not reflected in function main, and consequently in product I remains 5. I does not change. We will see how to change the value of I in our next section, which will be passed by reference. So till then, I implore you to write some functions and try to experiment with functions and see the beauty of functions, how sum is a different function, how product is a different function. Both are doing two different things. So this allows you to call only product in some other file or other program, allows you to call only sum in some other file and program. And if you would have written sum and product, then it may not have been usable in some other program, because this is doing two things. You may not want to. Say you go to a shop and you want to buy 100 grams of let's say coriander, right? But the shopkeeper says, no sir, we have only pack of 1 kg. You cannot buy 100 grams. Will you buy that 1 pack kg? No, because you need only 100 grams. So the function should be small and should do one thing. I must emphasize this point again and again that function should do only one thing, not more than one thing. This is where I'll stop and hope to see you again in next part. Till then, happy coding.